These will all be easier if we just think of an example. Okay, so I'm just going to get out one of these. Okay, here we go. You know you're a teacher when the biggest money in your wallet is a 50-cent coin. Okay, if we've got a coin, okay, and we flip it twice, that's all we're going to think about first. Okay, a fair coin, flip twice. Okay, so that's the situation that we've got, right? Now you've learnt over the past few years, there we go, that there are lots of different ways to illustrate this, okay? And to say, well, I can visualize what's happening here apart from actually just flipping a coin, okay? Now, in this case, you've got three options. Okay? And they go sort of in order of complexity, okay? So the first way is just to list out what are all the possibilities of things that can happen. What's the sample space? Okay, that's the phrase that we usually use, right? In this case, it works because if you flip a fair coin twice, there are 4 and only 4 possible outcomes. And you can name them for me. What are the 4 possible outcomes? What's one of them? You get 2 heads. Okay, a head and then a head again, right? What's another alternative? You get 2 tails, right? Good. 2 are missing. What are the alternatives? Head, tail, head first and then tail head. Okay, done. There you go. So now you got your sample space, now you've listed it out, and now any question I throw at you, you can just look at the alternatives there and say, look, there they are. Okay. Now, alternatively, you could do a dot diagram for this. Okay, you could do a dot diagram. So how would a dot diagram look like? For a scenario like this, we're going to have 2 axes, right? So it looks something like this, right? Now, what do the axes represent? You're going to have some options this way and some options this way. Now, in some senses, it's not that important here. You know, it's the same sample space for the first coin toss as for the second. Okay, but they might not be the same. So what we do is we distinguish. One of them is going to be the first toss, and one's going to be the second one. Right. So for your first one, you either get a head or a tail. Head or a tail. And then for your second one, you either get a head or a tail, okay? And now, as the name implies, it's a dot diagram, you've got 1, 2, 3, 4 alternatives. And of course you could fill them out. You could say, well, that's head, head. This is the top, right? That's tail, head. That's head, tail. That's tail, tail. You've got the same set of outcomes there, okay? When might this be a better alternative than just listing them out? Probably when you've just got more options. Okay. However, you're still limited, at least with this. You know, we've only got 2 dimensions on our page, so you're kind of limited to having flipped twice. If I flip it 3 times, you're already out of the running. Okay. If I did flip it 3 times, how could I represent it? Okay. What's our third option? List, dot diagram. One more. You could do a tree, right? You could do a tree that branches off like that. Okay. So a tree diagram. Now again, it's pretty simple, right? You've got to start with 2 alternatives, head and tail, right? And then after each of those, you either get a head or a tail, or a head or a tail. That's, if you want to get into terminology, okay, that's a tree diagram. To make it a probability tree diagram, what would I have to add onto there? What's missing? Yeah, that's right, the weightings for each of the branches, okay? Now, you can kind of get away with it here because all of the branches are going to have the same weighting. No problems, okay? But of course, you know, if I didn't make it a fair coin, if I made it a casino coin where tails is more likely or something like that, right? You're going to get different probabilities on each of these branches. But for this scenario, we'll just put on a half, and so on. Okay, so now that we have our ways of representing these, let's think about the product rule and how it works, okay? It's easiest to illustrate when you look at the tree diagram. Suppose I said to you, what's the probability of getting 2 heads in a row? Simple question, right? How do we compute it of this diagram? Like, how do we compute it? I don't want the answer. I know what the answer is, but how do you actually get the answer? Okay, as the name suggests, the product rule, not to be confused with the product rule in calculus, right? If you've got these two events, right, and they're happening together, right? There's a head and the other head, right? I want them at the same time. Then I multiply them. A half times a half, and that's the 1/4 that you expected. Okay? Of course, you can verify that by going back to the beginning, our list, and saying because it's fair, all of these are equally likely, and there are 4 of them, so it must be a quarter. Okay? Now that's the product rule. When you've got simultaneous events, I might even write that. The product rule is for simultaneous events. Or events that occur together. Okay?